Am I audible? Can you hear me? Try, okay, because even today some problem is there in Mixer site. Even sir can't log in. Okay. Okay. Think now is it okay? Kept volume full high. I don't know. Just a minute. Percent only. Am I audible now? Can you hear me now?
Sir, it's
Please,
breaking
please.
for me.
Again, please. Can you hear me? Please respond. Vijay Raghavan, am I audible?
Yes, sir. Yes.
Yes, sir.
Because
Yes,
some
sir,
problem.
it's feeble.
Thank you, thank you. Because there is some problem in that Cisco. Even I can't give the voice through laptop. That's why I'm talking over my phone. Okay, but slide I will move from the laptop itself. We can see the slide, right? Yes. Yeah. Thank you. Okay, let us. Just now our HOD sir called because there is some problem. Again, that's why I'll continue the class. Okay, just today I'll just give one or two examples of BOD problem. Okay, if you just go, we will go through that BOD problem. Now, please note down the problem number one. I will tell you how to solve this problem easily. Okay, 20 ml of sewage sample was diluted. 20 ml of sewage sample was diluted to 600 ml. Again, before solving this problem, I'll go back to your BOD in between so that you will realize that what is actually happening. 20 ml of sewage sample means you have taken 20 ml of water from Rishabhavati river, which is flowing next to RV College. Then you are coming to the lab and you are adding some dilution water. What is dilution water? I think sir has explained. Dilution water means you are going to add some water which contains micronutrients, so FeCl3, MgCl2, all those things, along with pH buffer and then sludge. That water is called as dilution water. That will be added to your 20 ml of sewage sample. Once you add into 20 ml of sewage sample, then total volume is 600. That means diluted to. Remember that point because that will be creating a lot of confusion during the examination. Okay. Diluted means total volume is 600. Okay. An
So what
equal
is
volume of
Rishabhavati?
this. Yeah.
What is Rishabhavati?
Okay. Very nice. Vrishabhavati means which is a river which is flowing next to our RV College campus. Okay. You can see that. That's why simply I told because you will be aware of that particular river
Sir,
which is
is it the one next to the hostel?
yes, exactly.
So it stinks, sir.
Yeah. Well, see, the smell is coming, bad smell, you know that. Once upon a time in 1978 or 79, people used to drink water from that Vrishabhavati, you imagine. Because that was very pure. Because of urbanization, then completely it is spoiled. It become drainage. That's why I mentioned sewage sample. 20 ml of that water only I told. Just you can understand very easily how bad it is. For that water, we are going to estimate the OD of the sample. Let us say forget about those things. Okay. See, we made 600 ml. We separated it into two equal half. You can see one half will be directly taken for the DO analysis. What is DO analysis? Dissolved oxygen determination. Immediately, that means the day one. Immediately, you are going to do dissolved oxygen determination. And another half, you will be keeping it for 5 days for incubation. Then again, you will be doing the same DO determination. That one only I am going to give it the problem. You can see. See, DO determination, dissolved oxygen determination, one bottle was determined and 200 ml of solution was taken and then titrated against standard sodium thiosulfate of N by 40 normal. It consumed 4.2 ml. That means it is your day one. In day one, during the titration, your the wastewater sample, which is one half, consumed 4.2 ml. Another half I told 300 ml separately kept. That is again kept in incubation. Incubation means you have to maintain a temperature 20 degree, along with moisture condition, along with another 5 days. After 5 days, you do the same 200 ml. From 300 ml, you have taken only 200 ml and you are doing the titration. Then it consumes 2.2 ml. Observe that. Here I have 4.2 ml. Here I have 2.2 ml. Why it is so? Because in the day one, okay, once again, not only problem, we should understand the theory also. In the day one, all my dissolved oxygen, which is there, available for titration. But day 5, some amount of dissolved oxygen is utilized by the microorganism. Utilized by the microorganism. That's why amount of dissolved oxygen in day 5 is less when compared to day 1. That one only I have given as a problem. How to solve this? One by one we will write. I think you are following that. Volume of sample before dilution, it is required. That means how much sample I have taken? 20 ml of sample only. Then volume of sample after dilution, 600 diluted to, that's why I told diluted to 600. That means total volume is 600 ml. Volume of Na2H2O3 required for blank. Don't write it as a blank. Day 1. D1, day 1. Okay. Volume of Na2H2O3 day 1 is 4.2 ml. Volume of Na2H2O3 solution required for the sample after 5 days. That means day 5, that is 2.2. You can see. Right. Normality of Na2H2O3 solution is N by 40. What is N by 40? 1 by 40 it is. 0.025 normal. Just to confuse you, we have given this value. Directly we would have given 0.025. Just to confuse you, that's why we have given 1 by 40. Then what is the volume of water sample taken for titration? For titration, that is 200. You can see here I have mentioned. Here also I have mentioned. Here also I have mentioned. Look at the problem. 200 ml of sample was taken for titration. Correct. These data are very important. Keep this data with you. Then step 1. D1 determination. That means what? Dissolved oxygen determination at day 1. Go back to your Winkler's method, sir has explained in the class. What is Winkler's method? I will take known amount of water sample. How much I am taking here? 200 ml of water sample I am taking here. Correct? Then MnSO4, alkali azide, NKOH, everything will be added and then shaken it properly. 1 test tube of sulfuric acid is added. Okay, that also shaken it properly. Then liberated nascent oxygen, add in Ki, take properly. Iodine will be liberated, titrated against standard sodium thiosulfate. Remember that. Then coming back to the problem, that means coming back to the calculation part of that. You see, N into V of burette solution should be equal to N into V of conical flask. Correct? Simple. What is burette? I have standard sodium thiosulfate. What is standard sodium thiosulfate? That is, standard means whose strength is to you.
One normal.
One normal.
Yes, need not be one normal. Known strength. Standard means it may be known strength. It may be one normal, 0.025 normal, or any normal. But here 0.025 because I have told it is 0.025 normal. Standard means what? Whose strength is known to you. Maybe the strength, no problem. Okay. Here it is 0.05 normal. That means volume how much is consumed. I told that 4.2 ml is consumed for day 1. 0.025 is there, that is normality. 4.2 is volume. This is known to you. And what about normality of water in terms of dissolved oxygen is unknown. But volume already known 200. Substitute that, you will get the normality N1. Easily you can calculate. That means N1 is equal to 5.25 into, that is not X, into 10 power minus 4 normal. Means in terms of dissolved oxygen. And you know that second next step is amount of oxygen available multiplied by gram equivalent weight of oxygen. That's all. Same normality into gram equivalent weight will give you the amount. But here is gram is there. Here milligram is there. Why? You check this. Okay, 5.25 into 10 to the power of minus 4 into 8. Okay, that will be coming in gram. Again, I multiplied by 1000 because I want to get that in milligram. That's all. I think as you can check using your calcium, you will get a 4.2 milligram of. This is for water day 1. Day 10. Same thing you extrapolate for day 5. Again, the water which is kept in incubation, 300 ml. In that you take 200 ml for titration. Okay? Same procedure you follow. That means in that you will be getting 2.2 ml as a titer value. 2.2 ml as titer value. Why? Because I already told here 4.2, here 2.2. Why it is so? Because here all the dissolved oxygen is there in the water sample is available for my titration. But in bottom, see, in after 5 days, some amount of dissolved oxygen is eaten by the microorganism. Once microorganisms eaten everything, then oxygen concentration decreases. Obviously, value will be less, 2.2. Then you will be getting this value here. Again, this is normal. If you want to get the dissolved oxygen in day 5, multiplied by gram equivalent weight again, convert it to milligram. Then you will be getting 2.2 mg. Once you get 2.2 mg, then this formula is known to you. Already sir has taught. BOD is equal to D1 minus D2. Means dissolved oxygen at day 1 minus dissolved oxygen at day 5 into volume of water after dilution by before dilution. Volume of water sample after dilution is 600. Before dilution is 20. 4.2 minus 2.2 it is 2. 2 here 10. Then answer will be 60. Forgot to put a dot here. 60 milligram per dm cube. Not 600. 60 milligram per dm cube. That will be your final BOD of the water sample. Next, I will ask you a question. Okay. Please somebody answer. I multiplied it with volume of water after dilution by before dilution. What is the reason? Can anybody tell? Class? Anybody? Please try. One, can you tell me?
Sir?
Yeah. Why you have to multiply it with by volume of water after dilution by before dilution? If you don't know, it is fine. Not a problem. Okay. I won't scold you. But you have to
I don't know, sir.
Okay.
I
Next.
don't.
Aniruddha.
Yes, sir.
Tell me why it is so. Why I have multiplied it?
Can you repeat the thing again?
Okay, in BOD final formula, D1 minus
Yeah.
D2 is volume of water after dilution by before dilution. Why you have to multiply that factor?
Change in concentration.
In which concentration?
Oxygen.
Not exactly. Okay, I thought I will ask the same question. Nobody asked. That's why I'm asking the question. Okay. Anyway, I'll tell you the volume of water after dilution, before dilution. Why I have to do? Because see, look at that. 20 ml of sewage sample is taken, and then what I did, have added dilution water. Dilution water. What is my aim? My aim is to identify. Observe carefully. My aim is to identify how much amount of dissolved oxygen is there in the 20 ml sewage sample. Correct. But even your dilution water also contains dissolved oxygen. Correct or not? That contains huge amount of dissolved oxygen. But if you are not multiplying this factor, then what will happen? You are not giving the account of dissolved oxygen which was there inside the dilution water. Correct or not? If you calculate along with that error, completely error it is. But we are nullifying the effect of dissolved oxygen which was there in the dilution water. That's why we are multiplying factor. This is the simplest problem. Easily you will get marks, because as I told, it will take 10 minutes for us to solve in front of you. But in examination, it is 1 minute job. Nobody should lose the marks for this particular. I hope it is understood, right? Anybody having any doubt? You can ask me. Otherwise, I'll go for next problem. Okay. No more doubt, means I thought
No,
it is
sir, understood, sir.
Yeah, understood. Thank you. Thank you very much. It's very important because very simple problem. You should not lose the marks. Okay. Next one. It is totally different. In BOD, that one problem is there. Another this type problem will be there. Okay. Calculate the BOD of effluent sample containing 8.2 milligram per dm cube of organic matter represented by a formula CH2O. What is CH2O? It is formaldehyde. HCHO, formaldehyde. If I give the problem like this, it doesn't contain blank value or it doesn't contain day 1, day 5, sodium thiosulfate, nothing is there. Directly I have given this much amount of waste is there. I have given the formula of waste, that's all. You have to calculate BOD of sample. Again, go back to the BOD definition. What is the BOD definition? Number of milligrams of oxygen required to oxidize all the biologically oxidizable impurities present in 1 dm cube of wastewater. Think something microorganism at incubation, all those things are there. But what is our main aim? To oxidize all the oxidizable matter present in the water body. That's all. Oxidation means what? You are eating some food, glucose. What actually happens in your body? You will get energy, right? See, if suddenly you will get giddiness, then immediately you will eat glucose. You will get energy immediately, and then, of course, it is not glucose, it is dextrose. Okay. Then what will happen in our body? If you take C6H12O6, it will oxidize, it will go into the body first, and already you are inhaling so much amount of oxygen. Oxygen will react with C6H12O6. What is the reaction? C6H12O6 plus O2 gives rise to 6CO2 plus 6H2O. That means you will be getting carbon dioxide that will be exhaled from the nose. Then you will be getting water molecule that will be excreted from the body along with little energy. Correct? That much only will happen. Here also same thing happen. The same concept is done by microorganism. That's all. The oxidation means microorganism will convert your biologically oxidizable matter into carbon dioxide. Means what? I have to do this reaction. Overall, this is only reaction. Correct? Any organic molecule will react with oxygen to produce CO2 along with H2O. Correct or not? This much only. If you understand this concept, you can do for any chemical. If I say this is formaldehyde, you write this reaction. If it is acetic acid, you write acetic acid plus O2 gives rise to CO2 plus H2O. Balance the equation. That's all. Then next you see 30 gram of acid HCH4 formaldehyde requires 32 gram of oxygen. How it is so? It's molecular weight. That's all. Forget about this. I don't want. Just for comparison, I have given But problem, I don't want this. You can see 30 gram of HCHO formaldehyde reacts with the 32 gram of oxygen. That much is required to complete oxidation. Then, very simple, 30 gram require 32 gram and 8.2 milligram requires how much? Just cross multiply you do. Okay? According to this balanced chemical equation, that means you have to balance it, but here it is already balanced. Balanced chemical equation. You can see what is balanced chemical equation is, number here both should be same. See 1, 2 plus 1, 3 oxygen, 2 plus 1, 3 oxygen, balanced. 2 hydrogen, balanced. 1 carbon, balanced. If it is not balanced, you have to balance it, then multiply and then you take it. Clear? According to this, 30 milligram, 30 gram or 30 milligram, both are one and same. 30 milligram of CH2O sample required 32 milligrams of oxygen. Then 8.2, how much? Just cross multiply, you do it. 8.2 into 32 by 30, that is 8.74 milligrams of oxygen is required. That means what? That is BOD. Because clearly mentioned here, you can see 8.2 milligram per dm cube. No need to make it separate calculation for that. Per dm cube means it is BOD. Clear? Such a simple problem, direct substitution. This problem will be there in the quiz. Easily you can solve this just by writing the proper balanced chemical equations for the complete oxidation process. Clear? Okay. Now, what about COD? Sir has completed COD? Anybody? Yes.
Yes, sir.
Vishnu, now I can able to log in. Login agana. Just it took a lot of time. I don't know why. So I completed all the COD problems. You just explain that normality to molarity conversion problem is there. No, just explain that.
Oh, okay. Just as sir mentioned, I will show you one problem. It is a bit different. Yes. Please note down this problem. In COD analysis, 25 ml of sewage sample consumed 8.3 ml of 0.001 molar K2Cr2O7. Calculate the COD of the sample. There are solved many problems on COD. Generally, in COD, I think you should come to your mind. If I tell COD, immediately you should strike to your mind. There will be a blank titration, there will be a back titration, and Ferrine indicator will be used. That's why I should give blank titer value, back titer value, all those things. But in this problem, I have not given the blank titer value, not given the back titer value. Directly, I have given something. That is 25 ml of sewage, of course, which is there in the conical flask. And it consumed 8.3 ml of 0.001 molar K2Cr2O7. It means actually. But in the blank titration and back titration, what you will do? Blank minus back you will do. That will give you volume of FAS consumed in terms of K2Cr2O7. You will get it. But here directly I have given. That is V1 minus V2 itself 8.3. I have clearly mentioned. And one small correction is there in this problem. You can see 0.001 molar K2Cr2O7. But during the calculation, what I will do? See, some generally we will express in normality. 1000 ml of one normal FAS is equal to 8 gram of oxygen. We will solve the problem like that. But unfortunately, I have given there is a molarity, not normality. That's why I have given here equation 1 molar K2Cr2O7 is equal to 6 normal K2Cr2O. Why it is so? Can anybody explain why it is so? Anybody? Right?
So could you repeat the question?
See, 1 molar K2Cr2O7 is equal to 6 normal K2Cr2O7. Why it is so?
Number
Because
of
in
ions
oxidation
is
of
released.
Because
oxidation state.
K2Cr2O7 loses 6 electrons on reaction.
Yes, very good.
So, and we have to use normality formula.
Yes, because in the first lab itself, we have told you how to calculate the equivalent weight of K2Cr2O7. Molecular weight by change in oxidation number. What is change in oxidation number? As Sachin rightly mentioned, see, Cr plus 6 converts into Cr plus 3. That means change in oxidation number is 3. How many chromium involved? 3 into 2, totally 6. That's why 1 molar, that means molarity is equal to normality is not there here. Molarity is equal to 6 normality. That means 6 change in electron. Very good. Okay. Same assumption I will continue. You see here 0.001 molar K2Cr2O7 is equal to 0.006 normal K2Cr2O7. It's much only I made. Look at this. This is your as usual formula of your COD. Okay. 1000 ml of 1 normal FAS is equal to 8 gram of oxygen. Why it is so? Because 1000 ml of 1 normal FAS is its molecular weight. Correct. 8 gram its molecular weight. It contains same Avogadro number of particles. Correct. That's why 1000 ml of 1 normal FAS is equal to 8 gram of oxygen. Then 1000 ml of 1 normal FAS generally we will express in milligram. That's why I made it 8000 milligram. That's all. Just conversion. Again, one more thing you should remember: 1000 ml of 1 normal K2Cr2O7 also equal to 8000 milligram of oxygen. Why it is so? 1000 ml of 1 normal K2Cr2O7. That means gram equivalent weight of K2Cr2O7 equal to gram equivalent weight of oxygen. Is also valid. Then you can see 8.3 ml of 0.0006 normal K2Cr2O7. Then you apply this formula. Okay. Then directly you will get a just cross multiplication, nothing else. Just you can do cross multiplication. 1000 ml of 1 normal K2Cr2O7 is equal to 8000 milligram of oxygen. Then 8.3 ml of 0.006 normal K2Cr2O7 is equal to 8000 into 8.3 into 0.006. Then answer will be 0.3984 milligrams of oxygen. You can see here 0.3984 milligram of oxygen. What it means actually? Look at the problem first. I told 25 ml of sewage sample is taken and did the analysis which is equivalent. That means which is requires 0.3984 milligrams of oxygen for complete oxidation. But go back to the definition of my COD. What is the definition of COD? Number of milligrams of oxygen required to oxidize all the oxidizable impurities present in 1 dm cube of water. That means definition says it is for 1 dm cube of water. For 25 cm cube, 25 cm cube of water sample, that is 0.3984 milligram of oxygen. Clear? But 1 dm cube, how much? You can calculate. Just cross multiply. Say 25 ml of water sample is this one and 1000 ml how much? Just cross multiply, you will be getting your final 15.936 milligram of oxygen. Generally it will be in ppm because I have mentioned mg. Sorry, actually this should be mentioned as mg per dm cube. Sorry, mg per dm cube should be, or it is ppm. Per dm cube or it is ppm. Okay? This is your problem based on K2Cr2O7. That's why only one assumption what you should make here is molarity to normality, or just to confuse you in the examination we may give you this one itself as normal, then no need to do this. But if you give molar, then you have to convert it to 6 normal. Okay? The simple problem which is on K2Cr2O7. That is the
Vishnu,
molarity
just
to
give,
normality.
Vishnu, just
sir.
give that oxalic acid problem is a idella. Just give
Fine.
that one. Let them solve. Otherwise, I'll solve it in next class.
Okay, sir.
Let them note down this.
It is there.
Just note down this problem.
Note down this problem. In COD analysis, 20 ml of sewage sample made to react with 25 ml of K2Cr2O7. After the completion of the reaction, that left out potassium dichromate required 15 ml of 0.05 normal FAS during the titration. Left out, it should be clear to you. That means it is back titer value. Same volume of potassium dichromate consumed 25 ml of 0.05 normal FAS when it treated with the distilled water, that is blank titer value, that is 25. If oxalic acid is only the impurity, then calculate the amount of oxalic acid. What and all we are telling here, it is very similar to COD problem, but we are telling that the impurity only it is oxalic acid. It is some industrial wastewater, only oxalic acid is the impurity present in that wastewater. Nothing else is there. Then calculate the amount of oxalic acid in 1 dm cube. Okay, please try to solve that. It is very simple. You can do it in 1 minute. I think sir will solve in the next class.
Yeah, you just note down this problem. You try it. If you are not able to solve it, we'll do it in tomorrow's class. Okay. But what is the impurity? It is mentioned here. Oxalic acid is the only impurity. That is a hint. Molecular mass is 90.
Then look at the structure and molecular mass is 90. COOH it is.
Okay, Vishnu, shall we stop here? Thank you. Thanks a lot.
Thank you.
Yeah. Okay, tomorrow we'll continue. If you are not able to solve this problem, I'll solve it tomorrow. Okay.
Okay, sir.
Yeah, shall we stop it here? Sorry, I could not join today because of some technical problems here. Yeah, thank you.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.